Have you ever stopped to think about how the phone in your hand or the computer on your desk actually thinks? How it can perform billions of calculations every single second? Well, it all boils down to some surprisingly simple math. Today, we're going to pull back the curtain on one of the most basic, most fundamental operations in all of computing, adding two numbers. And to get how a computer does it, we first have to remember how we do it. Let's get into it.
Okay, so before we even touch ones and zeros, I want you to cast your mind back, way back, to grade school. Remember the first time you had to add big numbers? It wasn't just guesswork, right? There was a system, a specific method you had to follow.
You'd line up the numbers, one on top of the other. You always start from the rightmost column. You add the digits, you write down part of the answer, and then, and this is the part that matters most, you carry the 1. That little concept, the carry, is the absolute secret ingredient. It's what connects the columns, and it's the exact same idea computers use.
So our grade school method works great with our 10 digits, 0 through 9. But what if we made things simpler? What if we had a system with way fewer digits to keep track of? And that's exactly where binary comes in. See, instead of 10 different digits to represent numbers, computers get by with just 2, 0 and 1. That's it. It is the simplest possible way to count, and that beautiful simplicity is what makes it perfect for the on or off world of an electronic circuit.
And here's the best part. The entire universe of binary addition, I don't care how huge the numbers are, comes down to just these 4 rules. 0 plus 0 is 0, 0 plus 1 is 1. 1 plus 0 is 1, no surprises there. But then you get to the fun one, 1 plus 1. Well, that's 2, right? And in binary, the number 2 is written 1, 0. So you write down the 0, and what do you do with the 1? You carry it. It's the exact same logic.
So this brings us to the actual problem we're solving today. It's a classic. You're given 2 binary strings, A and B, and you just have to return their sum, also as a binary string. So if A is 1, 1, which is 3 in decimal, and B is 1, which is, 1, the output should be 100, which is the binary for 4. So how do we get there? Well, let's not reinvent the wheel. We're going to take that exact same grade school technique that we all know and love and just apply it to a binary problem.
All right, let's work through this one together. We're going to add 1010 and 1011. We'll just line them up, and we're going to work our way from right to left, column by column. Okay, step 1. The column on the far right, we have a 0 plus a 1. Easy peasy. According to our rules, that's just 1. So our first result bit is a 1, and we have no carry. Our carry is 0. So far, so good. Now for the second column. Here we have 1 plus 1. This is our special case. The sum is 2, which we write as 1, 0. So we write the 0 down as our result bit, and we carry that 1 over to the top of the next column. Moving on to column 3, we've got 0 plus 0, and you can't forget this, we have that carry of 1 from the last step. So it's really 0 plus 1, which is just 1. So our result bit is 1, and the carry resets back to 0. And for our last column, here we go again. 1 plus 1, and our current carry is 0. So that's another 1, 0. We write down the 0 as the result bit, and we're left holding a final carry of 1. Uh-oh, we're out of numbers to add, but we've still got this carry of 1. So what do? It's simple, really. You just tack it on to the very front of the answer. It becomes the biggest, most important bit. So let's look at the bits we wrote down. We got a 1, then a 0, then another 1, then a 0, and that final carry of 1. The final answer is 10101. But here's the really interesting part. Because we worked from right to left, we actually built the answer string in reverse. And that's not a mistake. It's a super important clue for how we're going to code this. So doing it by hand is one thing, but a computer needs a strict step-by-step recipe. It needs an algorithm. So let's take what we just did and turn it into a formal process. This is basically the whole game plan. You start pointers at the very end of both numbers. Then you loop, and you keep looping as long as you have digits to look at or you still have a carry. Inside the loop, you add up the digits plus the carry. Now, to get the bit for your answer, you take that sum and find the remainder after you divide by 2. And to figure out the new carry, you just do the division. We'll look at that more closely in a sec. And then at the very end, what do? We reverse the result string, and we're done. Now, that algorithm might sound like a lot of steps, but what's really cool is that in a language like Python, you can handle the trickiest part of this with just one beautiful, elegant line of code.
And this is it. This is where the magic happens. A function called divmod does both jobs for us at the exact same time. You give it the total sum for the column, tell it to use the number 2, and bam, it instantly spits back both the new carry and the result bit. It's just incredibly clean and efficient.
So let's just break down that math, because it's so important. The modulo operator, that little percent sign, just gives you the remainder. Think about it. If the sum is 1, the remainder when you divide by 2 is 1. If the sum is 2, the remainder is 0. It perfectly gives you the result bit. Then, just doing plain old integer division gives you the new carry. If the sum was 1, dividing by 2 gives 0. If the sum was 2, dividing by 2 gives 1. This super simple math is the engine driving the whole thing.
Okay, so you might be thinking, this is cool, but why are we going so deep on just adding two numbers? Well, because this isn't just about a simple little sum. It's about something much, much bigger. For this particular problem, the binary strings can be up to 10,000 digits long. Think about that. That's a number so big you couldn't even write it down easily. And this simple grade school algorithm we've been talking about can handle it, no problem. It scales beautifully. This method of addition is the absolute bedrock that all other computer math, subtraction, multiplication, you name it, is built on top of. So what are the big ideas to walk away with? First, don't be intimidated by binary addition. It's really just a simplified version of the math you've known your whole life. Second, the carry is the key. It's the universal idea that makes it all work. And finally, remember that this powerful process is driven by incredibly simple math. The remainder gives you the result, and division gives you the next carry.
So we've cracked the code on how computers add. But that just blows the door open to a bunch of other questions, doesn't it? I mean, if this is how you add, how in the world do you subtract in binary? How can you possibly multiply or divide using just these simple building blocks? Well, that's a story for another time.